All right, I'm going to show you, made a little video here to show you how to make this, this windshield part, step 8 on activity 5.2. And it looks, the thing about it, it's a really good example of design and looking at things in terms of the geometry, because the thing that we need to know about is what is it I know about this part that I can use to help draw it geometrically. And for the most part, all I know are kind of these endpoints. They're highlighted here on my screen in yellow. It's the boxes that you have in your on your diagram. And I know the radiuses and some of the dimensions here. And I'm going to use that. And this is the way we actually build more complex parts, is we kind of find geometry that we can locate accurately and we can make a good location of. And we're going to build that. Now, if you look at this, you might look at this and say that it's one long line. Everybody sees the 3.04 line, and a vertical line here, and then a couple of arcs. But if you look more closely, these arcs are all marked with a radius, and that was 0.4, and a leader pointing to it. And that's how we designate circular features in dimensioning in engineering. And so this one has a radius of 6 pointing to it. So this turns out is really not a line, but it's an arc. And so instead of drawing a line there, I'm going to use a line to find that, but I'm going to use that and draw the arc there that has a 6-inch radius. And the other thing that's not obvious until I look carefully is this line is 3.04 inches long, according to this right here. However, this point up here is 3.01 inches from that same location, from that same point. So it turns out, even if this were a line, or the line I'm going to draw to build this, is not a vertical line, because if it was, it would be the same distance from here to here as it is from here over to that same kind of right side. So let me start this in Inventor. I have my sketch up here. I'm going to draw a line. And I like to stay away from the origin. I don't like to pin things at the origin just in case. Sometimes it creates problems later. And so this is 3.04. There's my line, and I can go ahead and draw front view to get it a little bigger where I can see it. Now the next one is that line. I'm going to build that vertical line to kind of show what I want to do is I'm going to build this arc first, because I know this point already. It's the end point of this line right there. The other end is up here somewhere in space, and I can't draw that. I don't want to estimate it and go, it's about there. I need to be exact. And so what I'm going to do is I'm going to put a line on here that's going to go up by a distance of 0.64, and it's going to come over. The difference in these two is 0.03, but I'll show you how we can let Inventor even do that much for us. Now the first thing I will do is I'm going to turn on construction over here, because these are actually not parts of my drawing that I'm building. I need to locate points for reference of something else. But I'm going to draw a line. It's going to go from this end point, and this time I want to be careful that it not be a perfectly vertical line, or I won't be able to do what I need to do with it. So I want to kind of build one at an angle, and I'm going to place that down there, and then I'm going to say done. And I'm going to use the dimensioning. Now we've always dimensioned like the length of a line before. We tried to dimension it, and that's not what I want to do here. Well, actually in this case, will it work? Yes, it will. Okay. There's another way you can do this, and I'll show you in just a minute. And that is, I'm going to dimension that as the 0.64 that we have. Okay, and you just saw that I could dimension it kind of in a vertical sense, but I'm going to show you one more thing. In the event that it comes in handy later, I can pick the endpoints of the line, and instead of picking, and notice if I do this, I get that same 0.64. Instead of going sideways, I'm going to go up, and I'm going to get this. And instead of saying the 0.03 that I know it to be, I'm going to put in the formula, because this was, the bottom was measured at 3.040. The top was measured at 3.010. So I can do that. I can subtract those two numbers from each other, and that gives me the correct dimension for this. It's trying to move it. Gives me the correct dimension for the location of this. Now the arc then is very easy to build. I need to turn off construction lines, because this is actually an arc I want. And I'm going to choose the 3-point arc. What I know about this arc is I know that it has an endpoint here, and I know that it has an endpoint here, and I know that it has a radius of 6 inches. Okay, and so 3-point arc in this instance is a little bit misleading, but it's going to work. And you'll notice that it's telling me, even now it's asking me if I want to put in the radius of the arc. So I'm going to pick the two endpoints. And I want this to bow out a little bit, so I'm going to move my mouse to the left so that it bows out and not in. But notice that it's giving me the dimensions to mention as a radius. And so I'm going to go ahead and put in 6 inches there for a radius. Right now it's at 3.432. I move it a little bit more and it's 0.883. I'm going to make it 6.00. And I have my arc drawn there. So I've created the first arc. Then the next challenge is to build this second arc, and that line I can tell goes from the endpoint of that one, and it goes up between 0.64 and 1, which is a distance of 0.36, and it goes to the right, then the difference between 3.01 and 2.55. Again, they're referencing the same dimension or datum on the left. They have the same reference line on the right, rather, I'm sorry. And so the difference, this distance right here, must be that subtracted that. So I'm going to use that to my advantage. Again, construction line. I want to start with the end of that circle. I don't want to build an arc now. I want to build that line. And I'm going to build it at an angle so that I can do exactly what I want to do with it. I'm going to pick the endpoints. And I said vertically or horizontally, rather, this was the difference of 3.04 or 3.01, excuse me, minus 2.55. Okay, and that comes out to be 0.460. And vertically, it is 1 minus 0.64 or 0.36. And so now I have the endpoints of my second arc. Turn off construction, build an arc. All the jokes that I can think of come to mind here. Yes, just insert bad joke here. And this one is a 0.4 inch radius. So I'm going to go ahead and draw it. You can see as I get bigger radiuses, it kind of bulges out, or smaller radiuses rather, it bulges out a little farther. So I'm going to make that 0.4. And there is my 0.4 inch arc. The last piece is much, much easier to build, the last arc in here, because I have the two endpoints already. I don't need to create a construction line. So I'm just going to stay with my 3-point arc, go from the endpoint of that arc to the endpoint of this line, bulging outward, and the radius is 6. And I have now finished my sketching. I'm done with that. Now if I go to a full front view, notice where these centers are. Normally speaking, I would really care where the centers are. And I do care. If I say I don't care, I don't mean it quite that way. It just means I don't know where they are, and trying to figure out geometrically where their centers are is a much bigger task than I want to take on, given that I had the information to put this together and build this. So I'm going to finish this part, and I'm going to extrude it. And it says extrude at 2.25 inches. And that is how you create the Automoblox B, or window, sorry. And that is how you create the Automoblox windshield by taking care of the geometry. And you can build a lot of more sophisticated parts this way, but the thing you're always asking yourself in your mind is, what points do I know I can locate in space? And then I have to do the constraining. The other key is to actually constrain them. Don't make it, don't rely on the numbers showing up when you kind of place the point down in Inventor. Go ahead and type them in so that they're exact.